Do you know what the mean distance of the Sun from the Earth is? It is 150 million kilometers. Can't we represent this large distance in an easier form? Yes, 150 million kilometers can be represented by 1.5 into 10 to the power 8 kilometers or by 1.5 into 10 to the power 11 meters. This representation helps us to grasp the actual distance better. The nearest order of magnitude of distance of the Earth from Sun is 10 to the power 11 meters or 10 to the power 8 kilometers. When we represent any distance or any measurement of physical quantity in terms of the nearest tens, hundreds, thousands or millions, we grasp the distance better. We further represent the measurements in terms of plus or minus powers of 10 to understand its vastness or smallness better. We can also represent a very big or very small number in a simpler way. Let us explore some more examples. What is the mass of one electron? It is 9.1 into 10 to the power minus 31 kgs. The nearest value of mass of electron can be written as 10 into 10 to the power minus 31 kg equal to 10 to the power minus 30 kg. So the order of magnitude of mass of electron is 10 to the power minus 30 kg. The average spacing between the molecules of gas is roughly 3 into 10 to the power minus 9 meters or in the order of about 10 to the power minus 9 meters. So from the above examples, it is clear that an order of magnitude helps in estimating a variable whose precise value is unknown. It is an estimate rounded to the nearest power of 10. So, if we want to generalize the magnitude of a physical quantity whose order of magnitude is to be determined, can be represented as its numerical value into 10 to the power x, which is its order. In the general representation, n is any positive integer and x can be any positive or negative integer. If n is equal to or smaller than square root of 1 into 10 or 3.16, then the order of magnitude of that quantity is 10 to the power of x. For example, in the distance 1.2 into 10 to the power 5 meter, 1.2 is less than 3.16. So the order of magnitude of the distance here is 10 to the power 5 meters. Similarly, if n is greater than 3.16, then the order of magnitude of the physical quantity will be 10 to the power x plus 1. For example, let the mass of a substance be 4.5 into 10 to the power 3 kilogram. Here, 4.5 is greater than 3.16, so the order of mass of the substance should be 10 to the power 3 plus 1 equal to 10 to the power 4. The orders of magnitude are generally used to make very approximate comparisons. Note that if two numbers differ by one order of magnitude, one is about 10 times larger than the other. If they differ by two orders of magnitude, They differ by a factor of about 100. As values get smaller, a decrease of one order of magnitude is the same as multiplying a quantity by 0.1. A decrease of 2 orders of magnitude is the equivalent of multiplying by 0.01 or 10 raised to minus 2. An increase of 2 orders of magnitude is the equivalent of multiplying the number by 100 or 10 raised to 2. In general, an increase of n orders of magnitude is the equivalent of multiplying a quantity by 10 raised to n. Thus, 2315 is one order of magnitude larger than 231.5, which in turn is one order of magnitude larger than 23.15.